we can apply another set of conditions to this solution. If we have an equation mx double prime equals negative kx, we get this general solution. If we put the condition on the solution that the maximum value of x prime is 0.4 and the maximum displacement is 0.6, well, x is the maximum displacement, so the displacement x of t has maximum value a, because of course the cosine is a function whose values vary from -1 to 1. Maximum value of the cosine would therefore be 1, so the maximum value of x of t would be a, and from the given conditions it conclude that a is 0.6. Now, the velocity of the x prime. X prime of t equals what? Well, the derivative of a cosine of omega t plus phi naught is negative omega sine of omega t plus phi naught. And the maximum value of x prime occurs when the sine takes the value -1, giving us maximum value omega a. Okay, so this occurs when sine of omega t plus phi naught equals 0 at whatever value or values of t this holds. We're going to get this maximum value. So that omega a equals 0.4. Now we know a is 0.6, we know omega a is 0.4, so we can very quickly draw the conclusion. Implies that omega, well, a is 0.6. What do we multiply by 0.6 to get 0.4? Of course, we can plug our symbols in and solve the equations and so forth. We find out that omega is 2/3. The interpretation of omega equals 2/3. The motion on the reference circle has period 2/3. We haven't specified the units of time, but if t is measured in seconds, that would come out 2/3 of a radian per second. The result would be motion along the x-axis with point moving around the reference circle at the given rate, omega.